In the last video, we have discussed about economics of power generation and some of the factors which will be useful in finding tariff in a power industry. In this video, we are going to discuss about five problems. The first problem is the maximum demand on a station is 150 kilowatts and annual load factor is 50%. Calculate the energy generated in a year. Say for example, per year, if you, when you want to calculate number of hours in a year, that is equal to C 365 into 24 is equal to 8760 hours per year. Here, in a given data, maximum demand is given and load factor is given. We need to find out energy generated in a year. Say for example, the formula for energy generated in year we have discussed in the previous video about energy generated in year is equal to maximum demand into load factor into 8760 hours in a year. That is equal to maximum demand into load factor into hours in a year. 150 maximum demand is 150 here and load factor is 0.5 and number of hours in a year 8760 total these many kilowatt hours. Here the maximum demand is given in 150 kilowatts. So I'm using directly 150 here. Say for example, if it is given in megawatts, you need to multiply with 10 power 3 because here we are expressing the number of units generated in a year in kilowatt hours. That's what we are expressing 150 directly. We are taking 150 directly from kilowatts. The second problem is a power station is to supply peak loads of 10,000 kilowatts, 8,000 kilowatts, and 7,600 kilowatts. The diversity factor is 1.5 and average load factor is 0.6. Load factor is given as well as diversity factor is given, and some of individual maximum demands. Individual maximum demands are given 10,000, 8,000, and 7,600 kilowatts. Maximum demand. The question is we need to find maximum demand on the station and energy supplied by the power station. Here diversity factor is equal to, we know the formula from previous video, diversity factor is equal to 1.5 given, that is equal to sum of individual maximum demands divided by maximum demand on power station. Individual maximum demands are given, diversity factor is given, load factor is given, energy generated in a year as well as maximum demand we need to find. Formulas are diversity factor is equal to sum of individual maximum demands divided by maximum demand on power station. This formula already we know in the last video. Maximum demand is equal to diversity factor is already given 1.5. Therefore, 1.5 is equal to sum of individual maximum demands is 10,000 plus 8,000 plus 7,600 divided by maximum demand. This maximum demand I am taking this side, and this maximum demand is equal to this by 1.5, that is equal to 17,000 kilowatts. From diversity factor I have found maximum demand. In the next line, what he asked is energy supplied by the station. Energy supplied by the station is equal to maximum demand into maximum demand already we have derived from previous formula into load factor already given in the data, and hours in a year. Hours in a year are 8760 from the previous problem we know. So finally energy generated in a year, these many kilowatt hours. Kilowatt hour is nothing but an unit. Well, we move on to next problem. A power station has a connected load of 50 megawatts and maximum demand of 25 megawatts. Units generated by plant are 6 into 10 power 6 units per annum. Annum means year. Calculate demand factor and load factor. Here connected given data is connected load is given 50 megawatts as well as maximum demand is given 25 megawatts. Units generated in a plant are, and also number of units generated in a year are given. Demand factor is equal to maximum demand divided by connected load. We know the formula. So from here we can find out here demand factor is we need demand factor. So maximum demand is already given in the formula in the problem divided by connected load. That gives you demand factor, as well as load factor is equal to number of units generated divided by maximum demand into time. Here also number of units given, number of units in a year given, maximum demand is given divided by hours in a year. This will give you a load factor. A load factor is in this case 0.2739 and demand factor is 0.5. The next problem, a power station uh, has a maximum demand of 20,000 kilowatts. Annual load factor is 50,000. Plant capacity factor is 40%. Determine reserve capacity. Reserve capacity, the formula for reserve capacity is equal to plant capacity minus maximum demand. Maximum demand already given in the data. So we need to find plant capacity. Plant capacity, here plant capacity factor is given 40%. Plant capacity factor is equal to, actually plant capacity factor is equal to number of units generated in a year divided by plant capacity into number of hours. Therefore, from the data, we can find plant capacity. Plant capacity is usually here number of units generated divided by plant capacity factor into 8760. Here, plant capacity factor is already given 0.48760. Number of units generated is we have derived from maximum demand. Load factor is given and time also given. Therefore, number of units generated in a year is equal to 87.6 into 10 power 6 units. These many units. So if I substitute these number of units generated in plant capacity factor formula, we'll get number of plant capacity 25,000 kilowatts. Here reserve capacity is equal to plant capacity. I already told you plant capacity is equal, reserve capacity is equal to plant capacity minus maximum demand. Plant capacity is 25,000 kilowatts as well as maximum demand is 20,000. So the plant is having capacity to generate 25,000 kilowatts, but it is operating at maximum load of 20,000. So we have a reserve factor of 5,000 kilowatts. So that it is called as an reserve capacity of a power plant. Next problem. A 100 megawatt power station delivers 100 megawatts for 3 hours, 50 megawatts for 5 hours and shut down for remaining time in a day. It is also shut down for maintenance for 50 days each year. Calculate annual load factor. 50 days in a year, we have 365 days. Out of 365 days, it is shut down for 50 days. Therefore, it operates, the plant operates for 315 days in a year into 24 hours. Previously, what we did is 365 into 24 hours, 8760 hours, we substituted for time. But in this case, 50 hours, 50 days, completely the plant is shut down. So therefore, 315 into 24 hours. That numerical we have to substitute in place of time. That is the difference here. And the power station delivers here given data. Maximum load is 100 megawatts. Here you see 100 megawatt plant means its maximum capacity is 100 megawatt. In that, it is loaded for 100 megawatts as well as 50 megawatts. Among those two, what is the maximum load? It is 100 megawatts. So maximum load, I have taken it as 100 megawatts, and it operates for 3 hours. Okay. The thing is, maximum from here, maximum load is 100 megawatts. In this problem, we need to find what is the energy consumed by loads per day, consumed or generated by power plant per day. For each day, energy supplied for each day is equal to this 100 megawatts into 3 hours plus, because 1 unit is equal to 1 kilowatt hour. 1 unit is equal to 1 kilowatt hour. These many kilowatts or megawatts for 3 hours. Therefore, 100 into 3 gives you the power transferred, power delivered by or energy delivered by generating station for this time, for this load. And 50 megawatts for 5 hours. Therefore, 50 into 5 and 100 into 3, both this is the energy supplied by power generating station to loads. This per day. For 365 days, out of 365 days, the plant is operated for 315 days. Therefore, the energy supplied per year is equal to 315 into 315. For this is for each day. That is for 315 days. 315 into this value. 315 into this one gives you 550 it seems. So 550 into 315, that is equal to 173250 megawatt hours. And also what he asked is calculate annual load factor. Annual load factor is equal to number of units generated in a year divided by maximum demand into time. I already told to you time 315 into 24 we have given. Maximum demand is 100 into, because it is given in megawatts. So 100 into 10 power 3, as well as here 173250 megawatt hours. I already told to you megawatt hours in terms of if it is megawatt hours into 10 power 3 we need to multiply. That's what here 3 into 10 power 3, here 10 power 3 I have multiplied, and finally load factor is 0.229. Thank you.